Hello and welcome back to another episode of Math with Son. Today we're going to go over all the things log and exponential. And I got it started off with just identifying the 6 main types of log problems that you could have. And here they are. There are only 6 different types that you could actually occur. And I have demonstrated already how you would start solving the problem, because after you start solving the problem, it normally falls into place. So you can have exponents on both sides, and if you have exponents on both sides, your job is to make both the 49 and the 7 the same. So I did that with the 7 squared. I will demonstrate how to do all these in later on in the video. But exponents on both sides, you make both of the bases the same. So I made both of them a 7, and then I set the exponents equal to each other, because the 7s equivalently cancel each other out. If you have logs on both sides, like we have here on number 2, they just poof away at some point. As long as it's one log for one log, then the part in the middle would just equal each other. The 3r plus 4 would equal the negative r. Then you could have exponents on one side, which is slightly different than number 1, because you can't really make a 14 into an 80.8. So in this case, we would log 14 both sides, and we would have left m is equal to log 14 of 8, which could be typed in the calculator a few different ways. If you have a log on one side, rather than if you had logs on both sides like we had here, you swish it around. 4 to the third would equal x to get rid of that log. And lastly, you have these unique situations, which are kind of like an exponent on both one side or an exponent or a log on one side. And that is if you have an e or an ln, you want to cancel it out by doing the opposite action. Ln cancels out e, so the ln of e goes away, and x would equal the ln of 33. Versus if you had an ln on both sides, you could e both sides to get p, which is what the variable is, equals e to the 4th power. Okay? So let's get into the review. Let's see what this looks like, all right? We got number 1. If we have to rewrite each equation in exponential form, that really just means that you're going to switch this around. If there is no base, like we have on number 1, it is automatically a base of 10. So when we switch this around, we are going to get 10 to the x would equal y. And that's it. That is rewriting it in exponential form. Versus if you had to write it in logarithmic form like we have here for number 2, this time we want to turn the exponent into a log, so we're going backwards. We're essentially going to write a log instead. Whatever this thing is, which in this case is a v, is the log base that I will take. So I am going to be taking a log base v of both sides. So this is going to be log v. I would have negative 7 over 6 equals log base v of u, which looks ridiculous, but that is the answer. It could also be written in some answer choices as log u divided by log of v. And that is known as the change of base formula, which sometimes you will even see it as like a fraction, log u divided by log v. Okay? Moving right along, this is going to be a quicker video as far as like how many problems we get through. If we had to solve something like number 3, this problem, we would need to first divide by 6, and that is going to give us a fraction. So I'm going to write what 41 divided by 6 is, which is a fraction. That's okay. 17a plus 5 equals 41 divided by 6. I want to keep it as a fraction because you never want to round these things early. If you round early, you're going to be just wrong. You're going to be further from the truth, and that's not okay. Just like we had here, where we had to log both sides, we have an exponent on one side of the equation, exponent on one side of the equation, right here, going back to those 6 in the beginning, you would have to log base 17 to cancel and log base 17 over here. So you would have a plus 5 equals log base 17 of 41 over 6. In order to find that value out, you could type it in the calculator. But in order to solve, we would also have to subtract 5. So a would equal log base 17 of 41 over 6 minus 5. And you can type that all in the calculator at one time. So we are going to have log base 17. I'm going to try and get it on camera. Here we go. Is it visible? It is visible. Barely. Need to get my graphing calculator. 41 over 6 minus 5. Oh, not like that. Minus 5 would be negative 4.32. I'm going to grab the graphing calculator for the other ones because this is not very good in the camera quality. Negative 4.32. So A equals negative 4.32, or the answer that I had above it. And normally you want to keep writing a few decimals. Okay? Number 4. If we have logs on both sides, they are going to be gone. They're going to cancel out. So we got 2n squared minus 5n equals 50 plus n squared. And if you have an n squared or an x squared and an x, or an n squared and an n, we have to set it equal to 0 and then factor. So I'm going to be moving this n squared over and moving the 50 over, giving us 2n squared minus n is n squared minus 5n minus 50 equals 0. And then from here, you can use whatever factoring technique you know, but I like to think, in most cases, because it's just an n squared, what multiplies to the last number but adds up to the middle number, which would be negative 10 and positive 2. Not even close. That doesn't, and positive 5, good grief. 10 times 5 is 50. 10 and 5 make the negative 5. So negative 10 plus 5 makes negative 5n. Boy, I almost messed that one up. Those are not your solutions. Your solutions would be when you change the sign or set your factors equal to 0. So we would get positive 10 and negative 5. Moving along. Oh, wait. Can't move along. When you get your answers here, you need to check and make sure you're not taking the log of a negative number, because you never know. Now, the 10 looks pretty securely fine, because if you plug in 10, we're going to have 2 times 10 squared, which is like 200, minus 50. That's positive. And when we plug in 10 over here, it's also positive. You can't take the log of a negative number or 0. If we plug in the negative 5, a little more risky, but negative 5 squared is positive. So that one's okay. Negative 5 times negative 5, positive. So this is going to be a positive number of some sort. And when I plug it in on the other side, negative 5 squared is also positive. So in this case, they both work out. I hope there's one that doesn't, just for fun. Number 5. Here we're upgrading. There are still logs on both sides, but they are not going to cancel out because the minus in between means that before I can cancel them, minus in between means we have to divide. On number 6, with a plus in between, we would have to multiply. So even though there's a minus in here and a plus there and logs here and whatever, that's still not going to change the problem too much. When we divide them, it becomes a single log base 6 and a log base 6 of 58 on the other side. And then from here, now the logs will cancel, but we had to divide them first because otherwise you might have subtracted that, and that's not okay. We got x squared plus 5 over 3 equals 58. How do we solve that equation? Well, we're going to multiply by 3 because we want to cancel that off the bottom of the fraction. And if we do 58 times 3, we get 174. X squared plus 5 equals 174. Subtract 5. Subtract 5. Subtract 5. X squared would equal 169, which when you square root, you get plus or minus, because we have to square root the 169, 13. So x equals plus or minus 13. Do not forget the positive and the negative, because you never know. The negative one might work. Sometimes, most of the time they don't, let's be honest. But in this case, the negative one would work, because negative 13 squared is positive 169, and the positive 13 squared is also positive 169. So both of them work out. You need both. All right, number 6, comparing it to number 5. With the minus in between, we divided, but with a plus in between, we are going to multiply. So this is going to become x squared plus 58x when I multiply and distribute that x. Equals the ln of 59. The ln's will cancel out, friends. The ln's are gone. Goodbye to you. X squared plus 58x equals 59. Oh no, you got an x squared and an x. You have to set it equal to 0 by moving that 59 over. And then you have to factor what multiplies to negative 59 but adds to 58. Well, that would be positive 59. I barely squeezed it in there. And negative 1 multiplied to negative 59 but add to 58. And that means x equals negative 59 and x equals 1. And finally, we have an answer that does not work. Negative 59, if you plug it back in, would be ln'ing a negative number. So that's wrong. And when you plug it back in, you always do need to plug it into the original, because it's the original that you're solving, not this combined version, this condensed version, so to speak, that I have here. Okay? Moving right along, we got number 7, some word problems. All right, so we got 11 upright dominoes increasing in height are lined up and knocked down. The dominoes are numbered from 0 to 10. I hope this is not the same problem I gave my students earlier. The smallest domino is 4 centimeters tall, and it is going to be topped over for a chain reaction. Each subsequent domino is 10% taller. What is the height of the 10th domino? This is slightly different. So you are going to use the A equals, helps if I write equals, A equals P 1 plus R to the T power, even though T is not going to represent time in this case. P is the initial amount. That would be 4 centimeters tall. We are increasing at a rate of 10%. So 10% as a decimal is 0.1 to the 10th power, because we want domino number 10. And then we just type it in our calculator. Let's see what that is. 4, 1 plus 0.1 raised to the 10th power. I am typing it in my calculator. I got 10.3749. And I don't see where it says to round. So I'm just going to keep it as that ridiculously long decimal. Okay? Next one. This one might solve for time. Let's find out. For a period of time, an island's population is growing exponentially. If it is growing at a continuous rate, so this is a different formula, it's going to be PE to the RT, no 1 plus, but the rate is still a decimal. It has a current population, so the initial population essentially is 1660. E is a button in our calculator. 0.02, we're looking for how long would it take to reach a population of 1872. So in order to figure this out, you would first have to divide by the 1660. So we're going to divide by 1660. That is a fraction. I'm going to see if it turns into a friendly decimal. 1872 divided by 1660 is a fraction. So I'm going to keep the fraction. I'm not going to deal with it. But that would get rid of this part, and we have 1872 divided by 1660 equals e to the 0.02 t. Well, how do we get rid of an e? Remember, e and ln are canceling actions, so we would ln both sides to cancel both of them out. ln here. So whatever the ln of this is, we would then have to divide by 0.02. So because this is just going to be the ln of this fraction equals 0.02t, we would divide this by 0.02. And you can type that whole thing in your calculator, as is ln of the 1872 over 1660, and then divided by 0.02 gives us a time of pert near 6 years at 6.0094. If you round early, you could get close to 6 years, but you might actually get 5.9 years, and that would be a little off, especially if the answer choices are very, very close together. Not to mention, a lot of answer choices love doing multiple choice in this full ln of this version type of thing, so that you kind of have to know what you're doing and can't just plug in answer choices. All right? Find the inverse. In order to find the inverse of anything, you have to switch your x and y. In this case, you just have a log equation when you do it. So this would be y to the 4th. In order to get rid of a log, we would have to switch this around. 6 raised to the x power would equal y to the 4th. In order to get rid and solve for y here, you would just have to 4th root it. So you could have the 4th root of 6 to the x is equal to y. Or fancy answer, you could say y is equal to 6 to the x divided by 4. Ooh, that's fancy. Because if you were raising it to the 1/4 power, that would be the same thing. Domain and range, ladies and gentlemen. So, really, in this case, it is the domain that is restricted. The range can be all real numbers. So I'm going to start with that. Range is all real numbers. But remember, the big theme is that you can't take the log of a negative number or 0. So if you were to set 2x plus 7, it can't be negative. It has to be 2x plus 7 has to be greater than 0 because you can't take the log of a negative number or 0 and solve that. You would get 2x is greater than negative 7, and x has to be greater than negative 7 over 2. So the domain is x has to be greater than negative 7 over 2 because you can't take the log of a negative number or 0, so that is what you set your domain, or the value inside the log, greater than 0 because it has to be positive. All right, we're almost out of here, but we still got some more. I'm sorry, there's so many. Expanding each log. If you have to expand the log, that means we need to take this and write it into multiple logs. So you're going to start with the dividing aspect, because if you're dividing, that would mean that you're really just subtracting. And then you would deal with these exponents. So we have a to the 4th minus b to the 4th, which would mean that we would be dividing by the b to the 4th. And then we would move these exponents in front. So we'd have 4 log 2 of a minus 4 log 2 of b. Ta-da! Done. Condensing is going and doing the complete opposite. We're going to take something like this and move it into like a single log, but we have to deal with the exponents first. So this would be log 7 of 3 to the 6th power plus log 7, 11 to the 5th power. And then when there's a plus in between, you would end up multiplying these. So this is going to be log, not 3, log 7, 3 to the 6th times 11 to the 5th. Now you could see it written like this, or you might actually see whatever 3 to the 6th times 11 to the 5th is, which is really, really big. So I think that we're going to keep it that way. But you could definitely find out what 3 to the 6th and 11 to the 5th is. But notice how it went from 2 logs to 1. Okay? Solving. If you had to solve this guy right here, we would need to make the bases the same because we have exponents on both sides, and it feels like we're going to make both of them a 6. So this is going to be 6 squared to the negative 2x, and 6 to the 3rd, because 216 is really 6 to the 3rd, and 6 squared is really a 36. We have to distribute the 2 and the 3 to both, and 2 times negative 2 makes negative 4x. Distributing the 3 would make 6 minus 6x. And then we just solve. We're going to add 6x over. Add 6x over. 2x would equal 6, which means x equals 3. Oop, a little off the screen. Okay? No big deal there. It's just set them there. Once they're both a 6, the exponents are just equal to each other. 2 more. We're almost done. All right, find the horizontal asymptote and the domain and range. So you can graph this to do this. But no matter what, this is the horizontal asymptote. No matter what. Okay? So if you graph this, first off, it would have been a decay function. So it would have looked like this. But would have had an asymptote down here at negative 2. Y equals negative 2. But then, because it's negative, it would flip over, so the real graph would look something like this, okay? And this x minus 2 would shift it to the right by 2, so it would kind of be a little bit further to the right whenever you were thinking about your y-intercept, but that is not important because shifting to the left and the right doesn't matter for domain and range. Well, we got our horizontal asymptote, it's negative 2, and that horizontal asymptote is going to dictate the domain and the range. Well, it's not going to dictate the domain because this domain goes left and right forever. But the range is going to be below that asymptote. So the range is going to be y is less than -2 or from -infinity to -2. Because it doesn't include the -2, I don't put a bracket around it. Last problem. Find the inverse of this. In order to find the inverse of this, we first have to switch our x and our y. So x would equal e to the y minus 9 over 4 raised to the 1/4 power. So you have to ask yourself, how do I get rid of this 1/4 power? And that would be by 4, raising it like to the 4th power. You could cancel this by raising it to the 4th power. So we would have x to the 4th equals e to the y minus 9 over 4. And then you have to ask yourself, how do I get rid of this fraction? Well, I just multiply by 4. So I have 4x to the 4th equals e to the y minus 9. We're getting closer. Add 9 to both sides. 4x to the 4th plus 9 equals e to the y. And last but not least, we would get rid of the e by ln'ing both sides. So the ln of this ugly mess would equal y. And that, ladies and gentlemen, would be the inverse and the end of this video. I will see y'all in the next one. Until next time, stay positive. Bye.